So we talked 3 years ago. I'm curious, in your view, what has been the biggest update of the last 3 years? What has been the biggest difference between what it felt like last 3 years versus now?
Yeah, I would say actually the underlying technology, like the exponential of the technology, has gone broadly speaking, I would say about as I expected it to go. I mean, there's like plus or minus, a couple. There's plus or minus a year or two here. There's plus or minus a year or two there. I don't know that I would have predicted the specific direction of code, but actually, when I look at the exponential, it is roughly what I expected in terms of the march of the models from like, smart high school student to smart college student to like, beginning to do PhD and professional stuff. And in the case of code, reaching beyond that. So, the frontier is a little bit uneven. It's roughly what I expected. I will tell you, though, what the most surprising thing has been. The most surprising thing has been the lack of public recognition of how close we are to the end of the exponential. To me, it is absolutely wild that, you have people, within the bubble and outside the bubble, but you have people talking about these, just the same tired old hot button political issues and like, are around us for like near the end of the exponential.
I want to understand what that exponential looks like right now, because the first question I asked you when we recorded 3 years ago was, what's up with scaling? Why does it work? I have a similar question now, but I feel like it's a more complicated question because, at least from the public's point of view,
Yes.
3 years ago, there were these, well-known public trends where across many orders of magnitude of compute, you could see how the loss improves. And now we have RL scaling, and there's no publicly known scaling law for it. It's not even clear what exactly the story is of, is this supposed to be teaching the model skills? Is it supposed to be teaching meta learning? What is the scaling hypothesis at this point?
Yeah, so I have actually the same hypothesis that I had even all the way back in 2017. So in 2017, I think I talked about it last time, but I wrote a doc called the big blob of compute hypothesis. And it wasn't about the scaling of language models in particular. When I wrote it, GPT-1 had just come out, right? So that was, one among many things, right? There was back in those days, there was robotics. People tried to work on reasoning as a separate thing from language models. There was scaling of the kind of RL that happened, that kind of happened in AlphaGo, and that happened at Dota at OpenAI, and people remember StarCraft at DeepMind, the Alpha Star. So it was written as a more general document, and the specific thing I said was the following. It's very, Rich Sutton put out the bitter lesson a couple years later, but the hypothesis is basically the same. So what it says is all the cleverness, all the techniques, all the kind of we need a new method to do something like that doesn't matter very much. There are only a few things that matter, and I think I listed 7 of them. One is like how much raw compute you have. The other is the quantity of data that you have. Then the third is kind of the quality and distribution of data, right? It needs to be a broad distribution of data. The fourth is, I think, how long you train for. The fifth is you need an objective function that can scale to the moon. So the pre-training objective function is one such objective function, right? Another objective function is, the kind of RL objective function that says, like, you have a goal, you're going to go out and reach the goal. Within that, of course, there's objective rewards, like you see in math and coding, and there's more subjective rewards, like you see in RL from human feedback, or kind of higher order versions of that. And then the 6th and 7th were things around kind of like normalization or conditioning, like, just getting the numerical stability so that kind of the big blob of compute flows in this laminar way instead of running into problems. So that was the hypothesis, and it's a hypothesis I still hold. I don't think I've seen very much that is not in line with that hypothesis. And so the pre-training scaling laws were one example of kind of what we see there. And indeed, those have continued going. Like, I think now it's been widely reported, like, we feel good about pre-training. Like, pre-training is continuing to give us gains. What has changed is that now we're also seeing the same thing for RL, right? So we're seeing a pre-training phase, and then we're seeing like an RL phase on top of that. And with RL, it's actually just the same. Like, even other companies have published in some of their releases have published things that say, look, we train the model on math contests, AIME or the kind of other things, and how well the model does is log linear in how long we've trained it. And we see that as well. And it's not just math contests. It's a wide variety of RL tasks. And so we're seeing the same scaling in RL that we saw for pre-training.
You mentioned Richard Sutton and the bitter lesson.
Yeah.
I interviewed him last year, and he is actually very non-LLM pilled. And I don't know if this is his perspective, but one way to paraphrase this objection is something like, look, something which possesses the true core of human learning would not require all these billions of dollars of data and compute and these bespoke environments to learn how to use Excel or how to use PowerPoint, how to navigate a web browser. And the fact that we have to build in these skills using these RL environments hints that we're actually lacking this core human learning algorithm. And so we're scaling the wrong thing. And so, yeah, that does raise the question, why are we doing all this RL scaling if we do think there's something that's going to be human-like in its ability to learn on the fly?
Yeah. So I think this kind of puts together several things that should be kind of thought of differently.
Yeah.
I think there is a genuine puzzle here, but it may not matter. In fact, I would guess it probably doesn't matter. So let's take the RL out of it for a second, because I actually think RL, and it's a red herring to say that RL is any different from pre-training in this matter. So if we look at pre-training scaling, it was very interesting. Back in 2017, when Alec Radford was doing GPT-1, if you look at the models before GPT-1, they were trained on these data sets that didn't represent a wide, distribution of text, right? You had these very standard, kind of language modeling benchmarks. And GPT-1 itself was trained on a bunch of, I think it was fan fiction, actually. But it was like literary text, which is a very small fraction of the text that you get. And what we found with that, and in those days it was like 1 billion words or something. So small data sets and represented a pretty narrow distribution, right? Like a narrow distribution of kind of what you can see in the world. And it didn't generalize well. If you did better on I forget what it was, some kind of fan fiction corpus. It wouldn't generalize that well to kind of the other we had all these measures of how well does the model do at predicting all of these other kinds of texts. You really didn't see the generalization. It was only when you trained over all the tasks on the the internet, when you kind of did a general internet scrape, right, from something like Common Crawl or scraping links on Reddit, which is what we did for GPT-2. It's only when you do that you kind of started to get generalization. And I think we're seeing the same thing on RL, that we're starting with first very simple RL tasks like training on math competitions. Then we're kind of moving to, kind of broader training that involves things like code as a task. And now we're moving to do kind of many other tasks. And then I think we're going to increasingly get generalization. So that kind of takes out the RL versus the pre-training side of it. But I think there is a puzzle here either way, which is that on pre-training, when we train the model on pre-training, we use like trillions of tokens, right? And humans don't see trillions of words. So there is an actual sample efficiency difference here. There is actually something different that's happening here, which is that the models start from scratch and, they have to get much more training. But we also see that once they're trained, if we give them a long context length, the only thing blocking a long context length is like inference. But if we give them like a context length of 1 million, they're very good at learning and adapting within that context length. And so I don't know the full answer to this, but I think there's something going on that pre-training, it's not like the process of humans learning. It's somewhere between the process of humans learning and the process of human evolution. It's somewhere between, like we get many of our priors from evolution. Our brain isn't just a blank slate, right? Whole books have been written about. I think the language models, they're much more blank slates. They literally start as like random weights, whereas the human brain starts with all these regions. It's connected to all these inputs and outputs. And so maybe we should think of pre-training, and for that matter, RL as well, as being something that exists in the middle space between human evolution and, kind of human on the spot learning, and as the in-context learning that the models do as something between long-term human learning and short-term human learning. So, there's this hierarchy of like, there's evolution, there's long-term learning, there's short-term learning, and there's just human reaction. And the LLM phases exist along this spectrum, but not necessarily exactly at the same points. That there's no analog to some of the human modes of learning. The LLMs are kind of falling between the points. Does that make sense?
Yes, although some things are still a bit confusing. For example, if the analogy is that this is like evolution, so it's fine that it's not that sample efficient, then if we're going to get the kind of super sample efficient agent from in-context learning, why are we bothering to build in, there's RL environment companies which are, it seems like what they're doing is they're teaching it how to use this API, how to use Slack, how to use whatever. It's confusing to me why there's so much emphasis on that if the kind of agent that can just learn on the fly is emerging or is going to soon emerge or has already emerged.
Yeah. So I mean, I can't speak for the emphasis of anyone else. I can only talk about how we think about it. I think the way we think about it is the goal is not to teach the model every possible skill within RL, just as we don't do that within pre-training, right? Within pre-training, we're not trying to expose the model to, every possible way that words could be put together, right? It's rather that the model trains on a lot of things and then it reaches generalization across pre-training, right? That was the transition from GPT-1 to GPT-2 that I saw up close, which is like, the model reaches a point. I like had these moments where I was like, oh yeah, you just give the model a list of numbers that's like, this is the cost of the house, this is the square feet of the house, and the model completes the pattern and does linear regression. Like, not great, but it does it, but it's never seen that exact thing before. And so to the extent that we are building these RL environments, the goal is very similar to what was done 5 or 10 years ago with pre-training. We're trying to get a whole bunch of data, not because we want to cover a specific document or a specific skill, but because we want to generalize.
I mean, I think the framework you're laying down obviously makes sense. Like, we're making progress towards AGI. I think the crux is something like, nobody at this point disagrees that we're going to achieve AGI in this century. And the crux is, you say we're hitting the end of the exponential, and somebody else looks at this and says, oh, yeah, we're making progress. We've been making progress since 2012, and then 2035 will have a human-like agent. And so I want to understand what it is that you're seeing which makes you think, yeah, obviously we're seeing the kinds of things that evolution did or that within the human lifetime learning is like in these models, and why think that it's 1 year away and not 10 years away?
I actually think of it as like there's kind of two cases to be made here, or like two claims you could make, one of which is like stronger and the other of which is weaker. So I think starting with the weaker claim, when I first saw the scaling back in 2019, I wasn't sure. This was this was kind of a 50-50 thing, right? I thought I saw something that was, and my claim was, this is much more likely than anyone thinks it is. Like, this is wild. No one else would even consider this. Maybe there's a 50% chance this happens. On the basic hypothesis of, as you put it, within 10 years, we'll get to, what I call kind of country of geniuses in a data center. I'm at like 90% on that. And it's hard to go much higher than 90% because the world is so unpredictable. Yeah. Maybe the irreducible uncertainty would be if we were at 95%, where you get to things like, I don't know, maybe multiple companies have, kind of internal turmoil and nothing happens, and then Taiwan gets invaded and like all the fabs get blown up by missiles and then
now you've changed the scenario.
Yeah. You could construct a scenario where there's like a 5% chance that you can construct a 5% world where like things get delayed for 10 years. That's maybe 5%. There's another 5%, which is that I'm very confident on tasks that can be verified. So I think with coding, I'm just, except for that irreducible uncertainty, I think we'll be there in 1 or 2 years. There's no way we will not be there in 10 years in terms of being able to do it end-to-end coding. The one little bit of fundamental uncertainty, even on long timescales, is this thing about tasks that aren't verifiable, like planning a mission to Mars, like doing some fundamental scientific discovery, like CRISPR, like writing a novel. Hard to verify those tasks. I am almost certain that we have a reliable path to get there, but like, if there was a little bit uncertainty, it's there. So on the 10 years, I'm like, 90%, which is about as certain as you can be. Like, I think it's crazy to say that this won't happen by 2035. Like, in some sane world, it would be outside the mainstream.
But the emphasis on verification hints to me as a lack of belief that these models will generalize. If you think about humans,
yes,
we are good at things that both which we get verifiable reward and things which we don't. You're like, you have a
no. This is why I'm almost sure we already see substantial generalization from things that verify to things that don't verify. We're already seeing that.
But it seems like you were emphasizing this as a spectrum which will split apart which domains we see more progress, and I'm like, but that doesn't seem like how humans get better.
The world in which we don't make it, or the world in which we don't get there, is the world in which we do all the things that are verifiable, and then they many of them generalize, but we kind of don't get fully there. We don't fully color in this side of the box. It's not a binary thing.
But it also seems to me, so even if in the world where generalization is weak when you only say verifiable domains, it's not clear to me in such a world you could automate software engineering, because software, like, in some sense, you are quote unquote a software engineer.
Yeah.
But part of being a software engineer for you involves writing these like long memos about your grand vision about different things. And
I don't think that's part of the job of SWE. That's part of the job of the company. But I do think SWE involves like design documents and other things like that. Which, by the way, the models are not bad. They're already pretty good at writing comments. And so with again, I'm making like much weaker claims here than I believe to to kind of set up to distinguish between two things. Like we're already almost there for software engineering. We are already almost there.
By what metric? There's one metric which is like how many lines of code are written by AI.
Yes.
And if you consider other productivity improvements in the course of the history of software engineering, compilers write all the lines of software. But there's a difference between how many lines are written and how big the productivity improvement is.
Oh yeah.
And and then like we're almost there, meaning like how big is the productivity improvement, not just how many lines are written.
Yeah. So I actually agree with you on this. So I've made this series of predictions on code and software engineering, and I think people have repeatedly kind of misunderstood them. So let me lay out the spectrum, right? Like, I think it was like 8 or 9 months ago or something, I said, the AI model will be writing 90% of the lines of code in 3 to 6 months, which happened at least at some places, right? Happened at Anthropic, happened with many people downstream using our models. But that's actually a very weak criterion, right? People thought I was saying like, we won't need 90% of the software engineers. Those things are worlds apart, right? Like, I would put the spectrum as 90% of code is written by the model, 100% of code is written by the model, and that's a big difference in productivity. 90% of the end-to-end SWE tasks, right, including things like compiling, including things like setting up clusters and environments, testing features, writing memos, 90% of the SWE tasks are written by the models. 100% of today's SWE tasks are written by the models. And even when that happens, it doesn't mean software engineers are out of a job. Like, there's like new higher level things they can do where they can manage. And then there's a further down the spectrum, like, there's 90% less demand for SWEs, which I think will happen, but like, this is a spectrum. And, I wrote about it in The Adolescence of Technology, where I went through this kind of spectrum with farming. And so I actually totally agree with you on that. It's just, these are very different benchmarks from each other, but we're proceeding through them super fast.
It seems like in part of your vision, it's like going from 90 to 100. First, it's going to happen fast. And two, that somehow that leads to huge productivity improvements Whereas when I notice, even in greenfield projects that people start with Claude Code or something, people report starting a lot of projects, and I'm like, do we see in the world out there a renaissance of software, all these new features that wouldn't exist otherwise? And at least so far, it doesn't seem like we see that. And so that does make me wonder, even if like I never had to intervene on Claude Code, there is this thing of like, there's just, the world is complicated, jobs are complicated, and closing the loop on self-contained systems, whether it's just writing software or something, how much broader gains we would see just from that. And so maybe that makes this should dilute our estimation of the country of geniuses.
I simultaneously agree with you, agree that it's a reason why these things don't happen instantly, but at the same time, I think the effect is going to be very fast. So like, I don't know, you could have these two poles, right? One is like, AI is like, it's not going to make progress. It's slow. Like it's going to take, kind of forever to diffuse within the economy, right? Economic diffusion has become one of these buzzwords that's like a reason why we're not going to make AI progress or why AI progress doesn't matter. And the other axis is like, we'll get recursive self-improvement, the whole thing, can't you just draw an exponential line on the curve? We're going to have, Dyson spheres around the sun in like, so many nanoseconds after, after we get recursive. I mean, I'm completely caricaturing the view here, but like, there are these two extremes. But what we've seen from the beginning, at least if you look within Anthropic, there's this bizarre 10x per year growth in revenue that we've seen, right? So, in 2023, it was like 0 to 100 million. 2024, it was 100 million to a billion. 2025, it was a billion to like 9 or 10 billion. And then
you guys should have just bought like $1 billion with your own products, so you could just like have a clean 10B.
And the first month of this year, like that exponential is, you would think it would slow down, but it would like, we added another few billion to like, we added another few billion to revenue in January. And so, obviously that curve can't go on forever, right? The GDP is only so large. I would even guess that it bends somewhat this year, but like that is like a fast curve, right? That's like a really fast curve, and I would bet it stays pretty fast even as the scale goes to the entire economy. So like I think we should be thinking about this middle world where things are like extremely fast, but not instant, where they take time because of economic diffusion, because of the need to close the loop, because, it's like this fiddly, oh man, I have to do change management within my enterprise. I have to like, I set this up, but I have to change the security permissions on this in order to make it actually work. Or, I had this like old piece of software that, checks the model before it's compiled and like released, and I have to rewrite it. And yes, the model can do that, but I have to tell the model to do that. And it has to take time to do that. And so I think everything we've seen so far is compatible with the idea that there's one fast exponential that's the capability of the model, and then there's another fast exponential that's downstream of that, which is the diffusion of the model into the economy. Not instant, not slow, much faster than any previous technology, but it has its limits. And this is what we, when I look inside Anthropic, when I look at our customers, fast adoption, but not infinitely fast.
Can I try a hot take on you?
Yeah.
I feel like diffusion is cope that people use to say when it's like, if the model isn't able to do something, they're like, oh, but it's like a diffusion issue. But then you should use the comparison to humans. You would think that the inherent advantages that AIs have would make diffusion a much easier problem for new AIs getting onboarded than new humans getting onboarded. So an AI can read your entire Slack and your Drive in minutes. They can share all the knowledge that the other copies of the same instance have. You don't have this adverse selection problem when you're hiring AIs because you can just hire copies of a vetted AI model. Hiring a human is like so much more hassle. And people hire humans all the time, right? We pay humans upwards of $50 trillion in wages because they're useful, even though it's like, in principle, it would be much easier to integrate AIs into the economy than it is to hire humans. I think like the diffusion, I feel like doesn't really explain.
I think diffusion is very real. And and doesn't have to, doesn't exclusively have to do with limitations on the AI models. Like, again, there are people who use diffusion to as kind of a buzzword to say this isn't a big deal. I'm not talking about that. I'm not talking about, AI will diffuse at the speed that previous. I think AI will diffuse much faster than previous technologies have, but not infinitely fast. So I'll just give an example of this, right? Like, there's like Claude Code. Like, Claude Code is extremely easy to set up. If you're a developer, you can kind of just start using Claude Code. There is no reason why a developer at a large enterprise should not be adopting Claude Code as quickly as, an individual developer or developer at a startup. And we do everything we can to promote it, right? We sell Claude Code to enterprises, and big enterprises like, big financial companies, big pharmaceutical companies, all of them, they're adopting Claude Code much faster than enterprises typically adopt new technology, right? But again, it takes time. Like, any given feature or any given product, like Claude Code or like Cowork, will get adopted by the individual developers who are on Twitter all the time, by the like Series A startups, many months faster than they will get adopted by like a like large enterprise that does food sales. There are a number of factors, like you have to go through legal, you have to provision it for everyone. It has to, it has to pass security and compliance. The leaders of the company who are further away from the AI revolution, are forward-looking, but they have to say, oh, it makes sense for us to spend $50 million. This is what this Claude Code thing is. This is why it helps our company. This is why it makes us more productive. And then they have to explain to the people 2 levels below. And they have to say, okay, we have 3,000 developers. Like, here's how we're going to roll it out to our developers. And we have conversations like this every day. Like, we are doing everything we can to make Anthropic's revenue grow 20 or 30x a year instead of 10x a year. And again, many enterprises are just saying, this is so productive, like, we're going to take shortcuts in our usual procurement process, right? They're moving much faster than, when we tried to sell them just the ordinary API, which many of them use, but Claude Code is a more compelling product. But it's not an infinitely compelling product. And I don't think even AGI or Powerful AI or Country of Geniuses in the data center will be an infinitely compelling product. It will be a compelling product enough maybe to get 3 or 5 or 10x a year growth, even when you're in the hundreds of billions of dollars, which is extremely hard to do and has never been done in history before, but not infinitely fast.
I buy that it would be a slight slowdown. And maybe this is not your claim, but sometimes people talk about this like, oh, the capabilities are there, but because of diffusion, otherwise, like, we're basically at AGI, and then
I don't believe we're basically at AGI.
I think if you had the Country of Geniuses in a data center, if your company didn't adopt the Country of Geniuses in a data center,
if you had the Country of Geniuses in a data center, we would know it.
Right? Yeah.
We would know it
Yes.
if you had the Country of Geniuses in a data center. Like, everyone in this room would know it. Everyone in Washington would know it. Like, people in rural parts might not know it, but like, we would know it. We don't have that now. That is very